At this point, we need to talk about the tonicity of fluids, because that does influence the movement of fluids. It has to do with the concentration of solute in the water. It's used to describe fluids within the body. And again, you can refer to this as the osmotic pressure of a solution. Hypotonic, a hypotonic fluid is less concentrated than an intracellular fluid. An isotonic fluid, they have the same concentrations. And a hypertonic fluid is more concentrated than the intracellular fluid. Here we have a picture of what happens if you take a cell and put it into a hypertonic solution or a hypotonic solution. If you drop a cell into a hypertonic solution, water is getting pulled out, so the cell is going to shrink. There's a high solute concentration in the fluid that is surrounding the cell. So the intracellular fluid is getting pushed out to try and balance, to even out the fluid concentration between the two. Whereas in the hypotonic solution, there's lots of plasma proteins or lots of electrolytes inside the cell. The body tries to even it out, and it does that by pulling fluid into the cell, and that forces the cell to swell. Tissues are made up of cells, so when we say out of the cell, that means into the blood vessels, out of the tissues and into the blood vessels. So what? Okay, let's say we're going to give an IV solution that's hypertonic. That's going to increase the solute concentration in the blood. It's pulling fluid from the tissues, and it's increasing the person's blood volume. That's great if the person is hypovolemic, but the tissues are still pretty well hydrated. It's problematic if there's not enough extravascular fluid to draw from. And it's also problematic if a person is not hypovolemic, because then you're pulling more and more volume into the person's blood system, and they're going to become hypervolemic and develop hypertension, and there's an increased cardiac workload with that. We're asking the heart to push too much fluid. Okay, let's give a hypotonic IV solution. That's going to drop the concentration of the blood, so the fluid is going to get shifted out of the blood and into the tissues. That's great if you've got good enough blood volume and the tissues are dry. But it's not going to treat hypovolemia, because whatever you put into the blood system isn't going to stay. It's going to go out into the tissues. And remember, this can lead to tissue swelling. We're looking at pulmonary edema and systemic edema if we don't keep an eye on this. If we give an isotonic solution, there's no difference between the concentration of the fluids and the concentration of the body fluids. But still, we can give too much so that we end up overloading the system if we don't be careful.